Okay, I want to look at the second problem on here, which is another rate of change problem or slope problem, but we don't have the picture to look at on this one. We're just working off from the table. We're going to kind of use the same strategies though to look at this, but it says that again it's a specified value of x. We're kind of interested in what the rate of change is at a particular point or x value, and this one is when x equals 1. So we're looking right here on the table. But I can't just use one point to get a rate of change. I got to compare this between 2 points. So I'm just going to use the ones nearby right here. What if I compare this one to the one right before it that's closest? We're going to do those 2 points. And then I'm going to come back and do these 2 points. One and the next one up, which is 1.2. So these are kind of the closest pairs around there. And I'm going to get the 2 results from right there. So the y values. The difference in the y values, that's 0.25 minus 0.16 over this. So x2 minus x1 would be 1 minus 0.8. So that comes out to 0.09 over 0.2. Which is 0.45, 0.45. You divide that out. And do the same thing with the 1 and the 1.2 over here. The y values are 0.36 minus 0.25. So that's 0.11 over 0.2, or 1.1 over 2, so that's 0.55 on that one. And then I would think, since this is the 2 points a little to the left of 1, and this is the 2 points from 1 to the right of 1, maybe my rate of change would be somewhere in between these two. If I kind of just average these two, maybe somewhere around 0.5 should be the rate of change. That would be a pretty good estimate of what's happening at that point. Again, we're trying to figure out what's going on at one point. We're using 2 points close by to get a good picture of that, and then we want to look at what happens as we get closer to that. That's the concept. That's where the concept of a limit is going to become the big answer for us as we move ahead.